Afternoon, so I'll go straight to David, who's going to talk about, well, you can read it. Over to you, David.
1, 2, 3. Yep, I can hear me. Gosh, that's loud. Okay. Thank you. I'm going to whiz through these. Do we need to turn the lights off? I don't know. Oh. They're all right for me, but it's the audience. Okay. Right. I'm going to be whizzing through these slides because, A, there's a lot of them. We haven't got much time and so forth. So that's me. Let's see if I can do this right. The idea is to get a better antenna for all these good reasons. And that's a typical back garden, mine in particular. And so it's not long enough, not high enough, too visual, too heavy, you can read all that. The thing is, it's not very satisfactory overall. So the Wyndham is where it's based, and we're bringing this up to date. And why use an off-centre fit dipole? Well, all these other dipoles, as you can see, are all heavy. Therefore, you get the catenary effect, and it doesn't really help if you have to have a pole in the middle of the garden. So the off-centre fit dipole is lighter weight and gives more bands. By the way, I hate trap dipoles, they're so heavy. So you get more bands and lightweight, so you only need a lightweight pole to hold it up. I hope to improve on even that. There's the history. I shan't go through it because we haven't got enough time, but thanks to G3UNA who did all this research for me. And you can even go to W4RNL, who's one of the gods, and look at his site because you've even got more detail there. The evolution is we started off with that single wire, the tapping point, back in 1928, so-called a Wyndham. It's not actually a Wyndham, but never mind. We won't go there. They were actually looking for a 600 ohm tapping point, and it evolved into this ladder line idea using the 1/3, 2/3 split, which actually is not optimum, but it gives several bands, and none of them include 15 meters. And then at the end of this slide, you'll see there the efforts done by DJ0IP, Rick, who spent hundreds of hours developing this antenna, and it's not even the 1/3, 2/3 split. His is the 40-60% or thereabouts. So this dipole is inherently unbalanced, and therefore it is inherently gives you common mode current, and the common mode current can bite, and it gives you a third antenna for picking up noise, which is not good. We'll get to there. You think your antenna might be balanced? That's the perfect world. Straight, flat, parallel, great ground, everything's wonderful until a bus drives by. Or, or you have strung it over a house, over a shed, or the ground isn't perfectly homogeneous. All sorts of reasons why it's not going to be balanced. So common mode current is not good stuff. I've just explained all that. So the best way to get rid of that is to use a link coupling antenna, and that's how it was done for years, and that's what they did back in the 30s, link coupling. And in the modern link coupled antenna, so-called modern, that's this good old Z-match, we all know it. I've used one for ages, but it takes for ages to set up, and it's got 2 outputs, blah, 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 blah. And if you want high power, you've got to go to one of these things or something like it. And that's what they look like inside. And it's still 3 knobs to twiddle, a lot of setting up to do, and actually they're not necessarily efficient. And if you want to check your tuner against the ARRL readings, DJ0IP has all of them. There's several pages, go over here. Check your tuner against there, and you'll see that some of them actually are very lossy indeed on certain bands and in certain impedance matches. I believe, now you correct me if I'm wrong, I believe these are all done by static resistance loads. There were no reactive components in the loads, so it might even be worse. It would be worse for some bands and some antennas. So of course nowadays we all use T-match antennas, don't we? And they've got their own losses and potential problems as well. And Owen Duffy did an evaluation of 5RV, good old G5RV, with a 300 watt tuner, and he found that actually it's only 26 watts delivered to the antenna. So you're losing 75% of your power from your output of your transmitter by the time it gets to the antenna. So not a good idea. Everything points to having a new antenna. So this is what happens if you have a perfectly balanced antenna. Everything looks cool. But if it's not a perfectly balanced antenna, you need, actually I've still got balanced antenna on there, I should say unbalanced. Oops, never mind. You get hot chassis syndrome, and of course modern T-match antennas, most of them for doing balanced antennas, unbalanced antennas, parallel feed lines, they have a 4-to-1 voltage balance, which doesn't work very well at all. You actually need a 4-to-1 current balance, and then you're much better off. Now that came along in 1985, and he showed us really what was actually happening inside the coax and outside the coax. In fact, a coax is perfectly balanced, but only on the inside. If your antenna is unbalanced, the part of the current will run down the outside of the braid due to skin effect. And of course, if you're on receive, you might have your antenna at 300 feet high, miles away from anywhere, but your coax or feeder comes down past your window, wherever it's going to go. That is a third antenna for receiving more crud from the local plasma TV. Thank God they don't make them anymore. So this is the classic 1/3, 2/3 off-center fed dipole, as a lot of people still make. And the idea is that the balun in the middle there transforms the impedance, which is there, to 50 ohms, and it is at that particular point, but that you only get that impedance with that ratio on a couple or at most 3 bands. So you really need, if you want a lot more bands, you need a different ratio. And this is what you need in the middle. The top one is a single core G3UNA. The trouble with that is it only works perfectly if your antenna is in the sky and you're in the sky and there's no ground and there's nothing anywhere around. You really need 2 cores wound the same way, but then interconnected in that method. And these are the guys to talk to. They discovered all that, and they'll do the mathematical proof, etc. So that works great, and it gives you multi-band performance, and it's fantastic. And that's the sort of graph you can get from it. Now, Rick did these initially with, he's got his antenna on a spider pole, and it's 50 feet high, and at the bottom of the spider pole you get the top one, and you can see most of the bands are in, but there's quite a lot of surplus, as it were. But when you put 50 feet of coax on the end of it to get it into the shack, you actually see that things improve. As we know, longer coax means more losses, but actually the losses are good in this particular case because it softens out the SWR on the bands where it's resonant. So why bother going to the end-connected version? Well, I think its adaptability is a lot easier to support. When I saw this advertisement for the WeMo version, I thought that's absolutely magic. You don't have the parallel feeders or coax or whatever it is coming out of the middle and upsetting yourself, upsetting people, garroting yourself as you walk past, the whole thing. I thought that was brilliant. And this is the WeMo version. This is what they call the City Wyndham. Developed in the 50s, I think. It's quite heavy. It does 100 watts PEP, fine. No 30, 15 or 6 meters, and it's 150 quid. It was the weight that put me off, really. This is my version. Less than half a kilo, 100 watts with kite winder and so forth. I use G3UNA, and this is my 1 kilowatt version, which only weighs 1.3 kilos. And I've got them here, by the way. And you can have a look at this. This is the parts of the system I've got. And this is my 100 watt version. It's still a dipole. It's still a dipole. It isn't any different. If you can get the current into the dipole, it will radiate the same as anybody else's dipole, wherever you feed it. It just gives your rig a lot better life. and it's very convenient. This is the diagram I put in the CDXC mag. Common mode current occurs here. The idea is that the RF comes in at the bottom. This is a trap, it's not just a coil, because it self-resonates around about 2 meters. This is I've made dozens of these. 2 meter end-fed, end-connected dipole, which you often have vertical. I've got one for Raynet and it sits in my body pack there. The idea is you cut the coax back to there, that's where the braid finishes, and you carry on with the inner going up the pole. This is the feed point, so it is still center fed. It's an end connected center fed dipole. It's a half-wave dipole. Thank you to VK1AD. And if you move the feed point off the middle, what you get is the impedance rises, but it also gives you the multiband performance. And that's where you put the transformer. This is my equivalent diagram. So I've split out the electrical and the mechanical part of the thing. So this is your dipole going across the top here, and 4-to-1 setup. So it's about 7.3 meters there and about 33 meters there. That gives you an 80-meter dipole. It's still a dipole. The internal view of the coax, so the RF sees this, and when it gets to here, then the shield is what radiates. Here you put a choke, and that stops the common mode current going any further and creates the resonant dipole for you. That was my first attempt at copying the system that Rob M0RZF reinvented. That was his version of the City dipole, City Wyndham, devised by UA3AHM. And that's his diagram. But this is my little box, and it uses a ferrite rod and several turns of G316. And his was actually for 40 meters, as you can see. And the idea is he actually held this bit up, which is the G3UNA choke, on a fiberglass pole, and I think it was only 7 meters high, and one of those, but not in the box. Now his choke was actually 2 chokes, and I decided I wasn't going to use 2 chokes because that was too heavy. So I used a single choke, and it worked perfectly. Now choosing chokes, I'm sure you've all read and digested K9YC's stuff, haven't you? Loads and loads of pages of stuff, which is a brilliant tutorial. And from that I determined that 16 turns on a 31 material core was the stuff to use. Now I actually made 2 because I wasn't really sure how well it would work, and it turned out that 1 was perfectly good enough. These days I measure on a VNA, one of those with the shield, and I've got some various examples, and it works extremely well. If you want to go to the TXQ website, you'll see that up here you'll see this black bit here is where you get maximum loss impedance there around the 3 meg region. Now fortunately you don't need very much impedance on the higher bands. It's mainly on the low band, the fundamental band that you work on, where you need maximum impedance, and so that's really where you concentrate your effort. And that's what I got, 16 turns according to K9YC. Now he doesn't actually do the measurements himself. He actually got hundreds of cores from all kinds of vendors at different times, measured, I don't know how many he measured, hundreds he says, and his idea was he wanted to give advice that would work every time with every core that you buy. In my case I bought 500 cores, measured them all, and I can now pick and choose which cores will work best. So I've made a table of the cores I've got, and when I make an assembly every one has a serial number on it, so I can actually correlate what I've measured with what I get as a final assembly. And that's this one, dual. For the heck of it, I thought I'll see what happens when I measure two. So I've measured that one, and that, as you can see, gives S21 41 dBs of attenuation, which I think is pretty good. Each one of the cores has been measured separately. I actually made, just for the heck of it, well, you can, can't you? I did that to see what the difference would be. I haven't measured it yet, but it will be interesting to find out. You're welcome to have a play, by the way. Whizzing through. So that's the DG8 SAQ VNA, and this cute little idea here I got from Everett, which is 3 150 ohm resistors in parallel. So that's the dummy load when you're doing your setting up, and when you do the earth short, you just clip that across there, and it works very well. So it's a lot quicker to do it if you've got a little jig like that. That's the plot. So this is the interesting one, and you can see up here the various attenuations that you get at these particular points. And that's my table. I've only put in these ones which are relevant. You can see obviously that the impedance drops dramatically at the higher frequencies. Well, it doesn't actually matter, as it turns out, I'm very happy to say. So that's where you concentrate your efforts, on the lowest band. This happens to be on that dual core version, just for the heck of it. I've only just started using this VNA. It's a sharp learning curve, I have to say. But the more you get into it, the more you realize it's a very powerful tool. So these are my layouts. This one, the first one I did was on a 12-meter spider pole. That's how I laid it out, and the coax came along the ground, and I put 100 watts in, and I tried to measure the current on here using 2 current meters, and it was so low, it was amazing. Oh, and I had a ground stake here, so the choke is there. If you imagine, this wasn't this choke, by the way, it was a low power choke. I actually ground the outward going signal, so that's just grounds out the residual current. This is the very first one I did, and it was using this Rig Expert. Thank you, Dave, wherever you are. Thank you for selling me that. Brilliant piece of instrument. And this is what I got when I got it working. There's another version later which I'll show you shortly. You can see this is measured with 15 meters of W103, which is a pretty good low loss cable. Some people like it, some people don't. I happen to like it. It's very economic, and you get less than 4:1 right at the band edge. And 40 meters comes out really nicely, I have to say. Going on down, 30. Most off-center fed dipoles don't work very well on the walk bands because it's meant to be a harmonic antenna, but with this ratio it seems to work quite well. 20 meters is a bit of a disappointment, but I'll come back to that shortly. Again, that's with 15 meters of coax. 17, again a walk band, which normally don't work terribly well. Now 15, again, off-center fed dipoles don't work very well on 15 meters. Not strictly speaking a harmonic. 12 and 10. I didn't in these days measure 6, but later I do actually now measure 6 and 4 and 2, curiously. It works on 2 meters, amazing. So let's go back to that 20 meter one. If you do an evaluation, RG8X with 100 watts in, and you've got 30 meters of it, 100 feet, you lose 1.2 dBs. The better the coax you have, the less you lose. And therefore, you don't really need to worry about that loss. The loss is in the coax, remember. So the idea is that if you actually support what I call the heavy bit, which actually isn't all that heavy, and you've only got then to worry about the wire, when you're doing outdoor events and such like, people are a bit nervous about having stuff attached to their valuable property. But if it's just a lightweight piece of wire, particularly if it's something like this SOTA wire, they use DXUL wire, it's incredibly light. the right thing to do, I think, in my view. I'd love to do this one of these days. The East Coast has got loads of cliffs, but Bempton is a bird reserve, and I could string it off Scarborough Castle if they'd let me. After all, I was a Scarboroughan. Or you can raise a kite. Wouldn't that be fantastic? You've got lots of uplift up the cliff, and with a Kevlar cord and that very lightweight wire, I think that should work reasonably well. Shock cord and all those things. Rocks on the air. Where's that again? Send Nobby up there, yeah, he'll be alright. So throw a piece of wire off the end of the cliff. So the higher power version, I sent this to Mel, K6KBE. You might know him, he was a part owner of a partnership of M2 antennas, but they didn't just build antennas, they did all kinds of things. He's written books. Very bright guy. I visited him actually after Visalia, I remember that time. And that was his version. That's his Ruthroff, and I've got one here, my version, very similar to what he did. It's obviously a lot heavier, it's got more cores in it, but he showed me how to do that, and he ran that off his 140-foot tower. So that's a half wave on 80 meters vertical. Yeah, you could work the world on that. He chose later actually to only run it at 60 feet horizontally because he wasn't big into DX, but he wanted to talk to his buddies around town. And this is now his go-to antenna on 80 meters. He used a thing called a BBDL, broadband delta loop. And it's a big thing in his back garden. By the way, his back garden is like acres on a hilltop. So more I've tried in my back garden. The whole point about this is that you get most of your radiation in the sky where it's really needed, and we're all worried about EMF these days. So the further away that is, the more comfortable you are this way. And I've tried it off my tree, that works pretty well. The polyester pulley on the top is just one of these. So the wire runs through, that's stuck in the bamboo, and the wire just goes straight through and it slides backwards and forwards. When the tree's whacking about in the wind, it just slides. It's fantastic. That works quite well. In fact, I actually ran this along the hedge. It was a hedge in those days before I changed to a fence, right round the garden, and now work Spain, no trouble at all. That's 6 feet off the ground, if that. That's what I use now, and I hope shortly to be able to raise that slightly more. So again, getting your center point high in the sky is what you can really use. I've used all kinds of wires, by the way, that 2402, and I've got various examples of wire here. I've got 1602, I've got some thin PTFE wire, I've got 2.5 mil squared. They all work. And that's my lab now, garden shed, amongst the forks and the rotary dub stuff. And by the way, there's always a ground stake involved. Now all my recent measurements are actually taken in the shed, in the lab, sorry. So I've only got 3 meters of coax, so the plots that I now take look a lot worse than when I had 15 meters of W103. That's what you can do with an 18-meter spider pole. So if you've only got one mast, you can take that, and the other end can go to wherever you like. Another tree, a ground point a long way away, the house if you like. It's a field day thing. I actually have a slide later on showing you how to put up an 18-meter mast very easily. This is my scheme for an IOTA thing if you have a small team. This is good for lots of bands. So that's what it looks like on 80 meters. If you're near the wet stuff, you can see that the DX angle 15 degrees, you've still got nearly 3 dBs of gain. So that's quite a nice antenna to have on 80, And of course, if you're IOTA, you're going to work a lot of stuff around UK, wherever you are. That's what it looks like on 40. You can really get some gain on 40. Nearly 7 dBs. What is that? Sorry, nearly 10. Whew. Slightly directional, of course. So if you can point it, then that's a good thing to do. Of course, on the other bands, as you go higher, it starts to break up. We all know that happens. So you could actually have one just for 40 meters for doing your MVIS off the same pole. And of course, if you put them both together, put a relay in there, you've got that advantage. You've got 40 and 80 and all the other bands coming in. By the way, the other end of this needs to be well out of the way of anything, so I made sure that this height is more than 2 meters. I go for 7 feet, whatever that means. And of course you can put even more aerials up. If you want to put a multiband 20 meter vertical there of the same design, then you've got omnidirectional on 20 meters, which the other ones don't quite give you. And that will work down to, they all work down to 6 meters quite nicely. Or you can fly a balloon. Maximum radiation as high as you can get it. And if you're in an urban situation, then I know you shouldn't have the antenna near the house, but if you have to, and you do have to, when you're in a small back garden, that's a way of getting the antenna high. And because it's only lightweight wire, you don't have the catenary effect with feeders and whatnot coming down in the middle. Wherever you can tie this to, it's convenient. And you can hang this off your soffit board or whatever you like there. And you can actually phase them as well. I did actually have a scheme for doing that. I won't bore you with that just now. And that's another way of doing it, phasing it, putting 4 around a tower. K8UR showed us how to do that. So the ultimate goal is to reduce loss from the transmitter to the antenna. That's the whole point. If you can remove the tuner, matching unit, and make the antenna do the matching, reducing the coax and tuner loss to a minimum, and that's where I'm trying to be. Take out the tuner if you can. This is another way. This was devised 1997 or even before then. It's called the Kent variation. It's good, isn't it? And so we've got, we're going back to the off-center fed dipole again, but it's the same principle. You put a capacitor there, the minute, forget the inductor, and what it does is it brings 80 meters more into line. And that's what I did. Now, take into account that this was done with only 3 meters of coax. I was using Hyperflex coax at the time. You'll see this is very pointy, so it's quite narrow. But if you go back to, that was done with 15 meters of coax. If that was done with 15 meters, it would be a lot flatter and a lot wider. Now, I can actually position that more or less where I like with that series capacitor. And in this one, I've put capacitors in there, right on the board. So it makes it very easy, relatively cheap to do, and you get some stunning results. So I want to make it even better. So my, let's just go back to this. Losses, the choke, by my calorimeter test takes about 2%. The Rutherford transformer, when I did the calculation, trying to remember Joule's law and all those things, temperature rise, you know, that it came out to about 7%. The coax loss, so the actual coax I use in these is about 9 meters altogether. And so on 50 megs, now you might not use this on 50 megs, but since it's possible, I thought, well, I'll do the calculation. So there's the losses on 50 megs. Not so good with this very thin coax, but the advantage of the thin coax is that you are getting a very lightweight antenna. And do you think they would know the difference? So that's quite interesting to look at. Yeah, my project ongoing is to actually have the Rutherford with the relay switching on it, so I can then tap down and get the appropriate match point for any bands which happen to be, you know, outside the ability of your tuner. For instance, that 20-meter one, I'm sure I can get that down to a better SWR. So the idea is, I'm hoping to be able to do the matching all in the antenna, so the coax loses the minimum loss and you don't have a tuner at all. And it's not big and heavy. So if you're on the DXpedition, for instance, and you've got antennas which need to be wide ranging, you don't need to take a tuner. And so the idea is, yes, it'll be more expensive, yes, it'll be heavier, but it'll be a lot less expensive and a lot lighter than carrying a tuner. And of course, less to go wrong, we hope. Let's hope for that. So this is my one-man erection system. Well, you can see it's self-explanatory. That's an 18-meter spider pole, and one of the actual falling derrick is used for tie points. This is just a spike in the ground, and I meant to bring it. So one thing I didn't bring was this little kit of parts here. You can use screw anchors, as I actually did. I'll show you the picture. These are the things I actually made. To make a very lightweight ground system for doing that. This is just 2-inch pipe cut back. I had some scrap 2-inch mast. It was what was called a rapid de-erection system. Doof, fell down one time and it bent the pipe somewhat. So I thought, rather than scrapping it, I made these, and you can make 2 of these out of one length. And if your soil is wet, you just water the ground a bit and stand on it. It will actually go into the ground quite nicely. Some bit of steel pipe, and this is I think this is 60mm and that's 50mm pipe. Well, that might be a bit bigger than 60, 90 I think it is. And that's just half a dog bone drilled in the end, and that you can stick right onto the top of the 18-meter mast. That's the thinnest section. And because the wire is very lightweight, it doesn't bend. Yes, it does bend a bit, but you know what spider poles are like, you can bend them quite a lot. So that you can get the maximum height from your spider pole and get the wire as far into the sky as possible. Very cheap, very easy. Accreditate, these are all the folks that have helped me really a lot. And here endeth. Any questions?
Any questions for David?
Stunning silence.
Stunned them.
Yeah, gosh. Sorry, I've run on rather a long time.
That's okay.
David, I noticed in one of your diagrams of your garden, you've got a pole sticking out the top of your tree. How on earth do you get that in there?
Well, living next door to me, I call him a sky monkey. He actually was an arborealist, is that the right word? One of them. And he just loves climbing trees. It's not his job anymore, but he's still got all the kit. I tied 3 15-foot bamboos together, they're quite beefy bamboos, and attached this poly insulator, and he climbed the tree. He actually climbed it with his 9-year-old daughter. And so they're up there together, and he tied it onto the limb, the highest limb, and threaded it through. Great. It's lovely to have somebody like that next door.
What's his phone number?
You're a long way off. Yeah, so that was that. So that was really good.
Any other? Whoa.
Hi, it's Tony. Have you, when you did your polar diagrams, did you take into account the effect of the earth losses?
Well, you know, when you're doing EasyNet, you can select that, and because it was by the seashore.
Oh, okay.
That was what I did.
Right.
Yes, it wouldn't be as
explains
good.
it.
Yeah.
It was surprisingly low. The
Yeah,
angle.
it is surprisingly low, but that's what happens when you buy. If you're on an IOTA expedition,
Okay, yeah.
you know, you've got that choice.
Okay, you were by the sea. I understand.
By the
that
sea.
now. Thank you.
Yeah.
Well, thank you very much, David. I think it's fascinating to see the work that you're doing. We all play with antennas, and you're just taking it to another level.
Oh.
And I think putting everything in there, and I particularly like the list that you've got up there. So we'll that will be useful to all of us. So thanks very much, David.
You're welcome to look at these bits and bats I've brought along.